This is a supplemental video for Algebra 2A students. This supplemental video is for the conclusion of Lesson 2.6 on drawing scatter plots and lines of best fit. And as promised, I want to show you guys how to come up with a line of best fit using your graphing calculator. The methodology that we talked about during the instruction from the video instruction says to plot all of these points on an actual graph, and then pick 2 points, calculate the slope, and then find the equation of the line of best fit. Certainly there are better ways to do that, and the way that we could be doing this is to use something on your graphing calculator called a linear regression. Alright, so your graphing calculator will allow you to perform a linear regression, and so you're going to be using the statistics menu. Let me choose a different color pen here so it's nice and bright so you can see it. We're going to be using the statistics menu on your graphing calculator. Sometimes on the 83s the statistics menu is in a different spot, but this is for the TI 84 Plus Silver Edition. The buttons are fairly similar on the 83, although the stat menu may be, you may have to use the second and then look maybe on top of one of these somewhere for the statistics menu. I don't know exactly where that is, and so I'll address it individually with your calculator. If you're using a Casio, unfortunately I don't have a good answer for you as of right now. So what we're going to do then is we're going to take a look at our graphing calculator, and so we'll turn that calculator on, and we're going to press the stat menu, and again your stat menu is this button right here. Alright, once you've pressed your stat button, what we're going to do then is we're going to go to edit the data, and so the very first option here says edit, and so we want to edit our our two data lists. So we have list 1 and list 2. List 1 is going to be the list of all the x's, and so in this case, as you're looking at this data here, the list of the x's are these numbers 1, 2, 3, 4, 5, and 6. So I'm going to type those numbers in, and simply pressing 1 and pressing enter, 2, enter, 3, enter, 4, 5, and 6. And so now I'm going to enter the second list of numbers, which are the y's. 84, 83, 86, 88, 87, and 90. Now, one of the things you're going to want to make sure of is you're going to want to make sure that your data matches. And so this data point, 184, should be this data point here. And 283 should be this data point here, and so on and so forth. You want to make sure that your x and your y match, and that you've got them in the correct spots or corresponding spots in your chart. Okay, so now what we're going to do then is we're going to go ahead and we're going to go back to our graphing calculator. And now that we've entered that information, you can get out of this by using either second quit, or you can hit the stat button again. So again, we're going to hit the stat button. Now what we're going to do is we're going to calculate a linear regression. And so if I calculate, scroll over, you're going to use the right arrow button here. You're going to scroll over until you get to the calculate menu. And then once you find the calculate menu, you're going to use the down arrow a number of times until you get to linear regression, which is option number 4 here. Okay? So I'm going to clear this off of here and go back to the pen mode so I can actually perform these tasks. And I'm going to perform a linear regression on my data. Now, the linear regression is in the form ax plus b. So what you're going to be getting is that this number in front of the value that's given here for a is the number that goes before x. And as you think about a line in slope-intercept form, y equals mx plus b, we know that the m is the number before x, that's my slope. So when I get my two numbers here, the a is my slope, and the b, as always, is the y-intercept. So I'm going to go ahead and wipe this screen out, and I'll press enter. So once you've chosen linear regression from the calculate menu, that was option 4, and I'll go back through that one more time. Stat, calculate, find linear regression, and press enter. And now it says calculate a linear regression based on the data that I've currently stored under list 1 and list 2. And when I press enter, it's going to give me a linear equation. Y equals ax plus b, where a is 1.25 and b is equal to 81.9. Now, from the video from yesterday, we got y equals 2x plus 80 or something like that. These two equations are certainly not exactly the same. Y equals 1.26x plus 81.9. Certainly not the exact same equation, but the equation that we come up with on the graphing calculator is going to be way more specific because it uses a much more scientific way to calculate that line of best fit rather than just picking two random points like we did and calculating the slope between those 2 points. Okay? So depending on the data points you got with the linear regression, with the line of best fit, you may get something totally different than you got on the calculator. But they should be fairly close. I mean, the slope here is 1.2, the slope here is about 2, fairly close. If I would have gotten a slope of maybe like 5 or 6 here, that would tell me there's something obviously very wrong with these two values. All right? Obviously, the y-intercepts are pretty close to the same number between 80 and 81 as well. Okay, now the next then key piece of information is we've talked about this idea of coming up with a correlation coefficient. Remember we said that R is equal to the correlation coefficient, and we said that the correlation coefficient, if it's closer to 1, that means it's more of a linear trend. If it's closer to -1, it means it's a negative correlation, but again, very close to a linear trend. And as that number gets closer and closer to 0, we get less correlated or less specific in terms of our lines. So our points are maybe a little bit more spread out. All right, and so you actually can use your graphing calculator to calculate that correlation coefficient, that R value. So you have to be a little bit tricky about that, but under your stats menu again, you're going to go over here to the test option. All right, so we're going to go over here to tests, and under tests, you're going to be finding one of these that says it is the linear regression t-test. And so there are a number of options here, and so we're going to scroll down to linear regression t-test. It's a ways down here. There's a whole lot of stuff that you'll use for statistics in here. We're not going to be using it with this. All right, so it looks like it's option F, linear regression t-test. And again, for the 83, it might be somewhere else, but generally speaking, that's where you're looking, is around that lower portion there. And as I press enter on that, if I press enter on this option, it's going to perform a linear regression t-test. And basically it's saying your x's are list 1, which is where we put our x's. List 2 is my y's. And then frequency, don't worry about any of that stuff. Just leave everything set the way it is, scroll all the way to the bottom, and press enter on the word calculate. And it's going to spit you back a linear regression. Now, be very careful about this because this is in the other order. Remember before, A was equal to the slope, and B is the y-intercept. Okay, in the previous example, because we used AX plus B for my linear regression, notice that when you do the linear regression t-test, it is now A plus BX. So the coefficient of x is B, the coefficient of x is B, and so since the coefficient of x is b, that means that number is my slope. This number is my y-intercept. Well, I know that kind of seems a little silly that b is equal to the y-intercept, but that's my b. So in looking at this information, as I scroll down here below, we're going to scroll down here, and you'll see right here that A, again, A is my y-intercept. So my y-intercept here is 81.93, which is what we got before. My slope is 1.257, which is what we got before. And here's the key piece of information that the first linear regression did not give you, and that was the correlation coefficient. Notice here your correlation coefficient is 0.9, and as we said, that number is very close to 1, so that means my data, first of all, since it's positive, okay, that means that my data is very close to a straight line, and in addition to that, since it's 9, it's going to be a very, very strong positive correlation, meaning so as x increases, y increases, and since this number is very, very close to 1, that means that the data is very closely correlated to a positive correlation, all right? Or, I'm sorry, to a linear correlation. And so again, the closer this number gets to 1, the more true this is in terms of a linear function, all right? If this number was maybe something like how about 0.6? If it was 0.6, that means that the data is very loosely correlated. It's a positive correlation, but it's not quite as tight as what we have here for our data. So that's kind of what you're looking at for calculating a linear regression using your calculator. Again, you can use the very simple method by just doing a simple linear regression. The problem with using the linear regression is that you don't get the correlation coefficient. So if you want to use the correlation coefficient and find the value of R, you simply have to scroll down to linear regression t-test, which is option F, and then just press enter until you get to calculate. And again, be very careful about which ones are A and which ones are B and which one is R. Okay, so in the linear regression t-test form, the number b is my slope because that's the number, this number is my slope because that's the number that's before x. So hopefully that was helpful for you. Again, we'll be spending some time with this in class, but I wanted to make sure that everybody had a chance to at least explore that with their calculator. And certainly for those students that are absent, this will be helpful for you as well.